Hello, my name is Corbin Irwin, and I'm here today to talk about secure network architecture design. This is for CYB 525. Our objectives today are to examine a network diagram and discuss its elements and design features, examine a Greenbone intrusion scan completed on a private network, and discuss the results, discuss security issues with novel networks and their protocols. There's several different elements that we're going to see within our diagram, our network diagram, and I'd like to discuss those in brief detail right now. If you look on the screen, you can see that there is a laser pointer, which we'll be using to point out all of these different elements within our diagram, so please pay attention to that. So let's start with an IPS. An IPS, intrusion prevention system, monitors network traffic and detects malicious traffic and blocks it. A firewall is a network security tool that is responsible for filtering all incoming and outgoing traffic based on predefined rules and policies. A router is a device that is responsible for communicating between two networks. The router allows transfer of data packets and also routes the traffic to its intended target. An IDS is an intrusion detection system, which can be either software or hardware based, and it functions as an early warning sign for malicious traffic. If malicious traffic is detected, the IDS will log the traffic and will also set off an alarm for early detection. A network switch is a device that redirects traffic to ensure that the information received goes to the correct target. Typically, you'll see this with Ethernet. A DMZ, or demilitarized zone, is a subnetwork that takes certain components off of the internal network and puts them in a separate area. We'll see how this actually looks on the diagram for better understanding. An air-gapped system is a system that is not connected to the network in any way, and it serves as a safe gate against any type of malicious activity infecting the whole network. We can only transfer data to this in physical media. We'll see what that looks like in the diagram as well. Now for our diagram. We're going to start at the top here with the internet and then move our way down. So we have the internet. Coming in, first it goes to our intrusion prevention system. At this point, any malicious attacks that are known can be filtered through and blocked. After this, it goes to our firewall, in this case the pfSense firewall. We chose this for a couple reasons. Number one, it's a great piece of software that you were able to customize highly, but it also has add-ons such as the IDS that we're using, which is Snort. Snort's great for detecting attacks and logging them, but it also has some IPS features, so even more prevention. From the firewall, we can go either to the left or the right. On each side is a router. We're going to go left first. At router 1, the internet traffic is then redirected to a switch. From the switch, we can see that it flows to DHCP server, the email server, and our proxy server. All of these servers, the switch, and the router are housed within the DMZ. So as we can see from this firewall, a completely separate router and a completely separate line to the internet. So it is separate from our internal network. So let's look at the internal network now. From our first firewall, we go to our second router, our internal router, which then goes to another firewall, even more protection. Now, the reason we designed it this way is because some rules might be different for communication with our internal network than they are for our DMZ. This allows us to configure rules, roles, and policies in a different way so that we have better control over the computers with the system. From our firewall, we have 5 different switches, 2, 3, 4, 5, and 6, and each of our departments has its own switch. As we can see here, 25 units in each of these different departments are hooked to the switch, to the firewall, to the router, to the firewall, to the IPS, and to the internet. One thing of note down here in our research and development department, this is where our air-gapped terminal sits. So this computer is not connected in any way over the air, Wi-Fi, Ethernet, in any way to the network. So it can serve as a secure backup. It can be used for research that we don't want on the network. Basically anything that we don't want to ever be hacked, we can keep there. And the only way that we transfer information is on physical media, such as a USB stick, CD, something along those lines. So let's discuss our Greenbone scan results. We did a scan on a virtual network, which housed 5 different machines. All of the machines were running. 3 of them, as we can see here, were detected with vulnerabilities. This first one is our Windows 2019 server. The second one is our Windows 10 machine. And this third one is our pfSense firewall, which was run in a virtual machine as well. We can see that our 2019 machine had 2 vulnerabilities that were medium risk. Windows 10 had 1 in medium, and our pfSense had 1 that was low. So let's take a look at these results a little bit more in detail and see if we can make sense of these logs. So over here, we can see that our host had this IP. This IP ties to our Windows 2019 server. we can see that it found a vulnerability, which is DNS cache snooping vulnerability, and we can see the port that was affected, the 53 port, using UDP. We can see a summary of the attack or the vulnerability, the impact of it, and then the solution. So we get a one-stop shop here with these results. Let's move on. Down here, we can see our Windows 10 IP, and we can see that we found an issue, this time with the TCP port. A summary of this is much longer when we talk about the actual vulnerability, but it does provide a solution for this one as well. And lastly, here we have the IP for a pfSense firewall. Now this one has a vulnerability on the TCP port, as we can see here, and it is a TCP's timestamping port. Let's take a look at the summary for this one. It's kind of interesting. The remote host implications of the TCP's timestamp and therefore allows a computer to record uptime. Essentially, they can take a look at when the uptime of the firewall is, and it could be utilized as a way to see when the firewall is down. So the Greenbone scan gives us a lot of results. So let's talk about security issues and the implications of advanced and novel networks and protocols. Securing support ports and protocols is very important. When you look at your network, you need to say which ports need to stay open. Which ones are we actually utilizing? As we can see in our last scan, there were some that were vulnerable. Do we need to have those open? And if they are, can we secure them better by filtering? Like we saw in this last scan, we can see what attacks are most likely to happen on each port. This knowledge is important so that we can better be prepared to negate those attacks should they happen, or prevent them from ever happening. For some examples, we have cross-scripting with the FTP port and Heartbleed with HTTPS. Our next concern when we think about advanced protocols and novel networks is legacy hardware and software. Are they using ports that are more vulnerable? Maybe they're using HTTP instead of HTTPS. Those are things we need to consider. How are we going to negate attacks, minimize impact, and reduce our attack surface? Maybe sometimes we need to replace hardware in order to do so. So that's some consideration. And then what about new protocols? Some are being actively researched and developed, such as named data networking and recursive inter-network architecture. Both of these are being worked on and integrated, and those are protocols that may have vulnerabilities that we don't know about. So how do we mitigate future attacks? Knowledge of past attacks help. Knowledge of the inner workings of our network to start with is also useful, and looking at logs, general good security. Also keeping up to date with attacks and methodologies that our attackers are using will help us to avoid attacks in the future. In summary, we talked about network design components placed and configured correctly, which allows for high usability while maintaining high levels of security. We talked about how Greenbone can be used to analyze a network and quickly find issues and solutions to those issues. We talked about network security and how it requires monitoring of the network state, study of known attacks, and the knowledge of technology, both current and future, in order to properly protect it. Here are my references. Please let me know if you have any questions, and have a wonderful day.